Okay guys, welcome back to Math with Mr. Miller. I'm going to go through an example of a bearings question because I find in these questions really the trickiest part about them is not necessarily the trig that typically gets involved, but really just drawing the picture itself. Because once you get the picture drawn, it's typically just an application of trig or law of cosines or law of sines. Okay, so we're going to practice getting, what a bearing is and getting a picture drawn for it. So if you aren't sure what a bearing is, I'm going to go ahead and give you the definition up above. So a bearing is an angle measured clockwise from north. Okay, so we do need to know our cardinal directions here. So if I'm going to start out, it's a ship sails from point A. I'm going to go ahead and plot point A here on a bearing of 56 degrees. So I'm going to draw my cardinal directions. And since north is directly up, what I'm going to do is I'm going to measure that angle 56 degrees clockwise from north. Now I need to be kind of careful. I know this full quadrant here, if this were the coordinate plane, would be 90 degrees. Okay, so I know if I'm doing a bearing of 56, I should not be going more than that first quadrant. And really, I should only be going a little bit more than halfway. So I'm going to go ahead, starting from north. I'm going to draw a little bit more than halfway. And I know my ship is then traveling in that direction for 9.8 kilometers. Before it hits point B. Okay? And at point B, it's going to change directions on a new bearing. So I'm going to go ahead and redraw my cardinal directions here so I can get my new bearing. It says the new bearing is 112 degrees before it hits point C. So what we're going to do, I know that's more than 90 degrees here. So I'm just going to go more than just that first quadrant. I'm going to dip into the next one by about 22 degrees. So I'm going to go ahead and start from north, pass through that first quadrant and stop just a little bit in to the next quadrant over. So my ship is changing course and traveling 3.5 kilometers to point C. And then it says find the distance from point A to C. So they want this distance from A to C here. So there is my triangle. And I'm going to redraw it below so it's a bit clearer without all the extra lines and coordinate planes involved. So here's A, B, C. Apologies for kind of the cruddy drawing there. But there's A, B, and C. And I know this is 9.8 kilometers. And B to C is 3.5 kilometers. Now, if I want to find A to C, I'm going to kind of take a look at my law of sines, law of cosines. For both of these formulas, I have a minimum of 4 variables. I have 4 variables in the formulas, which means if I want to find or solve for one of them, I need to know a minimum of 3 variables. And that goes for both formulas. Unfortunately, though, right now as is, I only have 2 things labeled in this triangle, which means I need another one. I know my third thing is not going to be side A to C because that's what I'm solving for. So I probably need to find an angle here in this triangle. So I'm going to go back to the picture that I have. I'm going to go ahead and add in the bearings of 56 and 112 to hopefully help me get one of the angles in here. Now, you might have to think back to when you did some geometry, okay? If you notice, I'm going to highlight in this picture in green Okay, I've got 2 north, and those have to be parallel lines. And if I can highlight the south as well. Okay, those have to be parallel lines, which means when I connected them with the line from A to B in blue, I made that a transversal. And what happens when you make that a transversal is you end up with something called alternate interior angles right here in orange and right here in orange, which means that little angle inside my triangle between the blue line A to B and this purple south where I had my orange dot must also be 56 degrees because alternate interior angles are congruent. Now that's not an entire angle in my blue triangle altogether. If I want to use that, I'm going to need to know this other angle in here in pink. Fortunately though, I can get that real quick because I know the entire side down this side, down the right-hand side would total 180 degrees because it forms a straight line going from north directly south. And I know part of that angle is 112 degrees. So if I subtract off 112 degrees, I'm going to get 68 degrees for my little purple angle in here. Which means the entire angle at point B would be 56 plus 68, making it a 124 degree obtuse angle here at point B. With that information now, I can go ahead and use either law of sines or law of cosines to solve for A to C. Well, I can't use law of sines right now because in order to use law of sines, I need to have at least one pair where I have an angle and the side across from it. And unfortunately, I do not have a pair of that, so law of sines in this case is completely irrelevant to me. I have to use law of cosines. What you might notice, though, is law of cosines as currently written is not set up the way my points are currently labeled A, B, and C. Because I know angle B, but law of cosines as written is using angle A. So I'm going to readjust my law of cosines so that this is cosine of angle B. But if I have angle B in my cosine, that means side little b has to be the thing across the equal sign. And if that's the case, then I need to replace my sides inside as A and C. So this is really the law of cosines formula that I want to use for this triangle. Okay? And if I go and set that up, I'm solving for A to C. That's really my side B, little b. So I'm going to go b squared equals 9.8 squared plus 3.5 squared, my A and my C, minus 2 times A times C, cosine of the angle I found in my picture, 124. And if I'm going to solve for B, that means I need to square root that whole thing. Okay? So I'm going to go ahead and just draw an arrow so I don't rewrite the whole thing, which is going to give me, B is approximately 12.1 kilometers if I round to 3 significant figures. Okay, so there would be my missing side, my missing distance from A to C. Okay, and they could ask other questions too, like they could potentially ask, what is the bearing to return from A to C? Which we could do with some manipulation in the picture and finding some additional angles in there. Okay. If you have any questions though, please feel free to ask in class about bearings. I'm more than happy to go through additional examples. Otherwise, I'm going to go ahead and end it there. Thank you all for watching.